What are different forms of conditional proposition? You will learn about it in this tutorial, so be with me as I discuss and share to you this lesson. As a review, conditional is of the form if P then Q, where P is the antecedent and Q is the conclusion or the consequent. For conditional proposition, the symbol arrow is used, and for its truth value, it is true except in the case where P is true and Q is false. So you just have to remember that the conditional statement is true in all cases except when the first proposition or the antecedent is true but its consequent or conclusion is false. So, let me go back with my question earlier. What are the different forms of conditional proposition? These are the following. We have its converse, inverse, and contrapositive. So for the converse of a conditional P implies Q, it is just done by switching the positions of the propositions. So from P implies Q, the converse is Q implies P. That means to say that the antecedent P in the conditional becomes the consequent in its converse. Similarly, the consequent in the conditional becomes the antecedent in its converse. For the inverse of a conditional, you just have to negate the two propositions. So from P implies Q, you will make it as not P implies not Q. So basically, you just have to negate the two propositions. And how to negate it? You just have to add the word not in the statement. While for the contrapositive of a conditional P implies Q, so this is it. Not Q implies not P. So you switch the position of the two propositions and negate it afterwards like this. So this is the converse, inverse, and contrapositive of a conditional proposition. And these three are its related implications. Take note that conditional is logically equivalent with its contrapositive. So this is the conditional form and this is the contrapositive form. And similarly, its converse, Q implies P, is logically equivalent with its inverse. Not P implies not Q. Is there something that can prove the equivalence of conditional and contrapositive and the converse and its inverse? Yes, there is. When you construct the truth table of the conditional and contrapositive, and similarly with its converse and the inverse, you will see that the truth values for the conditional is the same with that of its contrapositive. And of course, the truth table of its converse is also similar or equivalent with its inverse. That is why the conditional is equivalent with contrapositive and the converse is also equivalent with its inverse. So let us have some illustrative example. We have the given conditional. If two angles form a linear pair, then they are supplementary. So this is of the form conditional statement, the if-then statement. If P, then Q. The proposition P is two angles form a linear pair, while the proposition Q is they are supplementary. To find the converse Q implies P, you just have to reverse or switch P and Q. Therefore, if two angles are supplementary, so this is our Q, then they form a linear pair. So the converse of this conditional, if two angles form a linear pair, then they are supplementary, is if two angles are supplementary, then they form a linear pair. What about its inverse? Not P implies not Q. So this is how you do it. If two angles do not form a linear pair, then they are not supplementary. So the same position, but you just have to negate both propositions. So for proposition P, you add the words do not, while for proposition Q, you add the word not. And this is the inverse of the conditional. Okay, so now let's move on with its contrapositive. So for contrapositive of a conditional, follow this format. Not Q implies not P. So we have, if two angles are not supplementary, then they do not form a linear pair. So for our Q, here they are supplementary, but since this is negated, we add the word not. And for our second proposition, which is not P, they do not form a linear pair. So still, we add the word do not to negate the proposition P. Okay, so now let's recall the answers that we had earlier. This is our conditional. P implies Q. If two angles form a linear pair, then they are supplementary. For its converse, follow this format. Q implies P. If two angles are supplementary, then they form a linear pair. For its inverse, if two angles do not form a linear pair, then they are not supplementary. So the inverse is not P implies not Q. While for its contrapositive, if two angles are not supplementary, then they do not form a linear pair. So the contrapositive is of the form not Q implies not P. My dear students, to find the different forms of conditional proposition, you just have to follow the format for its converse, inverse, and contrapositive. And as what I've mentioned earlier, the converse is logically equivalent with its inverse. Similarly, the conditional is equivalent with its contrapositive. In this example, if two angles form a linear pair, then they are supplementary is logically equivalent with if two angles are not supplementary, then they do not form a linear pair. And of course, the converse and inverse, if two angles are supplementary, then they form a linear pair is logically equivalent with if two angles do not form a linear pair, then they are not supplementary. This time, I want to challenge you guys by answering this application. State its converse, inverse, and contrapositive. And this is the given conditional. If today is Monday, then it is a weekday. Comment your answers and get a chance to win Surf one day. Who knows, you'll be the lucky winner. Have a great day, everyone. I'll expect your answers.